Section 4.4, Laws of Logarithms, Part 3. Change of base formula. Change of base formula is used so that we can evaluate things like, what is the log base 7 of 9? Our calculator doesn't do that directly, but we could change its base and do or calculate to a certain number of decimals, stuff like log base 7 of 9. Okay, that's the change of base formula. I have a base b, like base 7, and I want to change it to a new base, like ln, base e. Our calculator can do base e. We can change it from log base b, like 7, to log base 10, the common log. And our calculator has those buttons, and so you want to locate them on your calculator. ln for base e and log for base 10. If we can change from a base that our calculator doesn't do quite easily, like base 7, we can change it to ln, or we can change it to log. It doesn't matter which base you choose. You just choose one of them and you'll get the same answer. Okay, so in this example, what we want to do is kind of notice that b subscripted. So I'm going to put that on the bottom, the b. A is not, so I'm going to put that up on top. Okay, so if I want to calculate log base 7 of 9, I see 7 in the denominator. So I'm going to say ln of 7. 9 is sort of up top, so I'm going to leave it up top, 9. And that is the way that I can change from base 7 to the natural log base. And in our calculator, I can hit ln of 9 divided by ln of 7, and I get 1.129150. I couldn't directly do log base 7, but if I change to the natural base, the base e, ln, then my calculator can do a quick calculation, ln 9 over ln 7. And again, it doesn't matter. It doesn't matter what base you pick, you're going to get the same things. Okay, so if I were to take and say do log base 10, I see that 7 subscripted, so that goes in the denominator. The 9 is not, so that goes in the numerator. And again, in your calculator, you're going to look for the log button. If I say log 9 and I divide that by log 7, I get 1.129150. It's the same exact solution. I can change to base e, or I can change to base 10. These are both bases that your calculator does easily. We'll change from base 7 to ln or base 7 to log, and we can get a quick calculation for different bases. Okay, so let's look at these examples here. For this one, I'm going to use the natural log base. It doesn't matter which one, because you saw over here on the right that I could either choose base e or base 10. It didn't matter. We still ended up with the same answers. So just we don't need to change to both bases. You just need to change to one base. Let's say we change to base e. Okay, so we see that 5 sort of subscripted. So that means if I change to the ln, we're going to put that 5 in the denominator and the 2 up top. Okay, so the problem says use a change of base formula in a calculator to evaluate the logarithm to 6 decimal places. Okay, find your ln button, ln of 2 over ln of 5, and you should get to 6 decimal places, 0.43067 7 to 6 decimal places. Okay, now this one, just again, it doesn't matter if I do ln or log. This one we're going to do log just for variety. We're going to change from base 12 to base 10. That's understood to be base 10. Let's change from base 12 to base 10. Okay, so we're going to do our 12 sort of subscripted. So that means we would have log base 10 of 12 in the denominator. Up top, we would keep that 2.5. Okay, so look for your log button in your calculator. Log 2.5 over log 12, and that gives us 0.368. Oh, pen's acting a little bit up. Let's try 368.743. Okay, now depending on the type of calculator you have, if you go into the math menu, let's go over to the up arrow, and you should see option number A, log base. Not all calculators have this feature. If your calculator has this feature, I highly recommend you look up how to use it. It's very helpful, and you don't need the change of base formula. When you do this, your calculator will say log, and then it's waiting for you to put in a number here and a number here, and then you would just hit enter, and then it does everything the change of base formula just did for us. So look into that, but don't worry if your calculator doesn't have it. Okay, sketch the graph of g of x is equal to log base 4 of x. Okay, so we've already done these, but this is a good review. What we're using is log property, where if I have the base a and an exponential base a matching, remember those cancel out and you're just left with x. That's the property we're going to use for graphing. Okay, so when I plug in x's, I want to plug in x's like 4 to the negative 1. When I'm plugging in x's, I want to plug in 4 to the 0. When I'm plugging in an x, I want to plug in 4 to the first. Plugging in 4 to the negative 1, remember what happens. This log 4 and this 4 cancel out, so we're just left with the negative 1. So we would be plotting 1/4 negative 1. Okay, this cancels out. 4 to the 0 is 1, so we'd be plotting 1, 0. Plugging in 4 to the first, which is 4, we would get 1. You might have to go back to your slides with logarithms. The y-axis is our vertical asymptote. When I start plotting points, let's plot 1/4 negative 1. So that would be probably about here. When I plug in 1, 0, that would be here. When I plot 4, 1, that would be here. And as long as we remember that general shape, there would be our graph. We just have to remember that asymptotes are guides for which our graph approaches. Our graph doesn't stop here. Our graph approaches that vertical asymptote, so it continues on in the negative direction. So domain is negative to positive infinity. Yikes, sorry, that's the range. Domain is 0 to infinity, 0 to infinity, and range is negative to positive infinity.